Hello. Now I'm going to cover a little bit changes that I made to the sixth version of my Cuda SDL script in Python. And what to say about this script? I just explore the possibilities with SDL2 and the modern Python 3. And what are the changes here? First let's take a look at this threading. I decided that threading could be maybe useful in the future. How much it improves the performance in this case I don't know, but at least it doesn't degrade the performance significantly. And threading works here through this thread class, and I submit those named arguments to the class constructor, and then it has this specific func that it calls. This is the function that is called then from this thread with function arguments. And the nice trick was that I looked up also was with this dictionary update. This way we can avoid serious mess and just simply update those inner dictionary for this class via those new arguments that were submitted, those named arguments. And let's take a look how it works. Here in run function we see those threads are created. Thread 1. I need only one thread in addition to the main thread maybe. And this thread is then constructed here, and it has only named arguments. And this dictionary constructs those class arguments from those named arguments then through dictionary update. And we see here func equals this name, threaded GPU update, and function arguments for this updating function are here. Two arguments are submitted, and when we call this function from here it steps into action. And this is then aliased as func run, and we see here func run, self func, and here we see this important Pythonic paradigm of unrolling those hidden arguments or these arguments tuple self func args. And this star is preceding this this is a Pythonic syntax here. And this key KV args means keyword arguments. And this is preceded with 2 stars. And this is nothing like in C. This means a completely different thing. And what to say about this 3D GPU update that is called then with this function here. We see that it is submitted with 2 arguments, and I needed to make this Cuda color still global because it needs to be accessible in other places also. And then this Cuda color is sent to the device with this stream. And when I run this script, and then I first off I need to submit the display that I'm displaying it, and my second screen, second monitor is starts from 1. The first one is 0 and the second one is 1, and I press enter and we see this program running. Under the cursor there is a white square, and then when I press Q then it's quit. And other changes that I maybe cover here is display scale. Then I found that this number is sufficient to avoid frame drops, so it can run 60 frames per second. And nice thing about this SDL2 is that SDL2 automatically can scale up the content inside the window. And another thing that was pretty tedious here was this create window and renderer function. And here we see something interesting with this, how it is set up. We see here first of run. This is the main function that is run from the main. And first it sets up SDL2 and calls this create window and renderer function. And we see that here it uses this full screen desktop mode for the window, and this is useful also performance wise, I believe also. But this ensures that your display area covers the whole monitor canvas. And the documentation said that SDL2 utilizes this technique of putting your content into display of choice with those positional coordinates. And we see that positional coordinates are here I define them, and they are used here with width and height of the according display, and how to query those display properties and what is the displays you are connected to. Your computer has maybe more than one monitor, several displays. Then SDL2 is in SDL2 it is possible to put your content into display of choice. And we see here that it was pretty tedious. I looked in internet for those examples, but anyway it's difficult to understand and to really conform to your own needs the certain example that you have. And here the point is that this DM variable or display monitor or display mode is first initiated, and it is like C like Python. Sometimes Python has its own traditions, and and the way it must be used, but in some cases some merges to C like paradigms, they emerge from the Pythonic world, and then you need to understand how it is connected to this program. And this is an empty pointer really, or unfilled structure. And we populate this structure, this DM, with this call here. Then when we know in C language we submit those structure pointers to the functions, and then inside the function they get populated, and we don't return anything, just the function performs its work with such a way. And here we see the similar way that this DM is only a type, and then it is submitted to this get current display mode function. And I'm not explaining how this precisely works, but those are the notes for it. And what to say here, I also submitted this SDL renderer target texture argument here, and maybe this improves something performance-wise, but the point is that when we explore those texture creation methods, then we take a look here when the setup is done or pre-work. Then we see that texture is created in SDL, and this is the texture that the renderer is using then. And we then create this canvas or the real data for this texture, and this here is a NumPy array, and as we know, those NumPy arrays really reside in CPU memory, or the usual memory. And then the next thing in the next line is that we create a pointer for this array for those pixels. And I don't know if it takes a duplicate of this those pixels or creates simply a pointer for it. This from buffer method. But anyway, it is residing in CPU memory. And I wonder if we call this kernel here, then we submit this pixels array to the kernel. This is the pixels array. And the pointer then is used to update this texture for SDL2. And we submit this pixels array, and probably it is in this moment it is in the CPU memory, and then it is probably uploaded to the GPU memory, and after the kernel is done, then it is maybe submitted back to the CPU memory. I don't know, it is absolutely a huge amount of work that it does for every frame, because when we know the amount of those pixels that we have in the frame here, as I showed it running, then we see that the resolution is the ordinary monitor resolution here, but the number of pixels in this resolution is 1,400,000. You see, this is the number of pixels in this monitor area, and this means that for every pixel it executes a kernel function, or the kernel functions there that are executed from the kernel. 1,044,000 times. Uh, 4,400,000, and no, it's a huge amount of kernel calls that this Cuda makes those work groups there, and working trees there, and we submit this also this Cuda color to this. This Cuda color makes a random noise, and then we see this random noise there. And this Cuda color, I made this a global variable so that this color could be updated from this another thread here. Here it is the same variable here used.